Just wanted to let you know that this diagram is out there. That is another example that very carefully, if you look at it, all attributes are made private. All attributes are made private. All methods are made public in this particular instance. There are getters and setters. Each class has a constructor, right? It's important. The constructor includes input parameters, and there is a description of particular methods down here. Just a few, few examples. When we go into discuss designs, which would involve object hierarchy, which typically means that, okay, engineering and nursing students share a lot of common information, but they also have some specific information which will be stored in those classes. And so the common information bubbles up and goes to the top of the hierarchy, and we say then that the nursing and engineering students become subclasses of the students class, and that discussion follows. I just wanted to show you that this handout is out there. All right, we started talking about the exceptions, and we also started to talk about exceptions in our Java class. So let's see if we can quickly refresh our. I'm not planning to start any Java application here today, because we're already covered a lot of things. I just want to go through some of these highlights. So any unusual situation typically is described as an exception in a system. Some exceptions are raised by the CPU itself. For example, if CPU detects division by 0, it raises an exception. There's an exception handler somewhere in the operating system, which eventually, in case of Java, notifies Java Virtual Machine. Java Virtual Machine looks up at the program, finds out whether the exception is handled. In that case, the exception handler in the program is invoked, and it catches the exception, and the execution of the program continues. Otherwise, if there is no exception handler, most likely the program is going to terminate, because otherwise it would be considered to be impossible to continue if the program is attempting division by 0. On the other hand, we discussed it last week. If there was a situation with an attempt to withdraw too much money from a checking account, we could create our own exception. We could create an exception object and throw it and have someone else handle it in our application. By the way, if we go to CIS 157, I believe that sample is posted there, right? If we go to CIS 157, samples, Java samples, there are a couple of CIS 123 samples here. First of all, this banking application, which creates this overdraw exception, the project I tried to work on last week. But there's also sort of like an implementation of the baseball players, which was also another homework that we had, right? Where we have the main driver program for baseball players, abstract class baseball player, and there's also concrete class pitcher and catcher. So you can actually refer to these samples as the reference when you work on the UML diagram. So let's take a look at the baseball, for example. Right? So there's a main program that tries to work with baseball players. Well, perhaps we should spend some time in the future to talk more specifically, and their definition of the baseball player class right here. Just keep it in mind that those samples are there. But today, let's take a look at this copy of the Java exception demo, a banking application. So again, let's take a look at the main class. So if you recall, we had this sample. Perhaps it's still on this machine, but I just would like to use this sample right here. So it says, all right, you can have a customer, right? And recall from our design that the customer, when we say new customer, when the customer class is instantiated, it creates an account class, because customer is like a composition of a customer class, and its constructor creates an account class. And then the main program here says, okay, customer, get me that account. And so the main program does not say new account, because somewhere in the customer constructor, and we should be able to see it as well, in the customer class, when we have a constructor for this class, it says public customer, which takes initial amount, it basically creates brand new account. And brand new account is a private attribute of the customer class. So in the main program, what we say is that now we have the customer and the account, and we say hello, and we ask the user to give us some amount to withdraw, and we say the only transaction is to be able to do the withdrawal at this particular location. And so we're saying, please enter amount to withdraw. Now this is the part that I have not finished last week, but we started talking about this in our Java class. Remember the input mismatch exception? Here's another example of it. So it's basically for a while we're looping here, and we're saying, okay, enter the amount to withdraw, and we say input, which is the scanner class, right? The instance of the scanner class is named input in this example, and we say give us next double. If the user types something that doesn't look like a double number, or types some garbage, then we're going to then the scanner is going to throw this exception, input mismatch exception. So the syntax to deal with it and to prevent program from crashing is to say input next double, but wrap it in a try block, right? So wrap it in the try block, and the try block has another part that has a catch block, at least one catch block, which says that if this exception takes place, then what we're going to say bad input, and then just advance to the next line and essentially wrap around and go back to the top of the loop and execute it. In the finally block of this, we say under any circumstance, if what they type is 0 and it's a double 0 amount, we're just going to say goodbye, and this is our way of exiting from the program, kind of gracefully. Otherwise, finally block can be used to deallocate any sort of resources that were dynamically allocated in the try block. An example of such deallocation could be if we wanted to open a file, and in the midst of it there was an exception thrown. We want to be able to close the file regardless to whether exception did take place or did not, and whether we caught the exception or if we did not catch the exception. In that case, we want to say finally and be able to close the file. So there could be many different examples where the finally, so try, catch, and finally is similar to if-else construct. And it says if no exception takes place, this is the code that should execute, right? And it begins to execute. But in case if the exception is taking place, the exception is thrown, then we'll say catch, right? And we want to catch a particular type of exception, and then do some work based on that exception. And the finally block is executed always. So the catch block right here is optional. It only will execute if the exception indeed was thrown by this input object. But the finally block will always execute. The final block will always execute. So if there is no exception and the amount is not zero, we proceeding to the next part of our program. Essentially, we are exiting from this loop because the amount will no longer be -1. And we're basically saying, customer, process this transaction. So apparently the customer class is responsible for handling the transaction.